This is section 5.1, the guided notes. And in this section, we're going to be multiplying polynomials. In the last one, you were adding and subtracting them. And this is just going to do the multiplication now. And we're going to start by multiplying with algebra tiles. So there's some rules, and here are the rules. The first factor goes on the left side of the grid, and the second factor on the top. Fill in the grid with tiles that have the same height as the tiles on the left, the same length as the tiles on the top. Follow the key. The product of the two tiles of the same color is positive. The product of two tiles of different colors is negative. So here we go to the next page. I'm just basically reading you this first part so you can see it up on the screen. But basically they've drawn a grid. And you'll remember in an algebra tile, right, this is x and this is 1. And then this would be 1 and 1. And combined, right, that's where you get your 2. And let's see, the first factor goes on the left. So this 2, right? 2 in algebra tiles is equal to these two things, which is what they have. And then, x plus 1 is equal to these tiles. So then, basically, when we get 1 times x, you're going to get one of these. And 1 times x is going to be x. And then 1 times 1 is going to be 1. And 1 times 1 is also going to be 1. So you wind up, if you basically add up, what's inside this grid, so to speak, right? That's going to be 2x plus 2. So that's how you can multiply these with algebra tiles. Let's try a few more examples. And probably before you've seen this, I'll try to do some stuff in class as well on another worksheet. So here we go. We're going to put the first factor on the left, right? And if I were to write 2x in algebra tiles, it would be those two rectangles, right? And here's x minus 3 here. So when you get x times x, that forms the big x squared. And again, the big x squared. And then x times a negative 1 would basically be a negative x. So you're going to have 3 of these negative x's. I'm putting the lines through them, right, because that's the way I can tell they're negative in case I'm using my pencil. So, and I don't have access to multicolors. And this is also going to be a bunch of negative x's. So all combined, we have 2x squared minus 6x. So let's just keep trying some more examples. In this next example, we're going to basically turn this, we're going to do something different than the algebra tiles, just to learn a different way to multiply these things together. And you can rewrite this example A here as basically 3x times 3x squared plus 3x times 6x, and then minus, or you could say plus 3x times a negative 5. Because you've essentially distributed the 3x to all of these terms. So let's see what that looks like in the next page, or at least the next page for me, probably same page for you. So here we go. We've distributed this stuff, and if I take 3 times 3, right, I get 9, and then I get x to the first times x squared, right? This is like x to the first times x squared. You can add the 1 and the 2, so that's x to the third. Right, and this is like 3x to the 1, 6x to the 1. We just learned this last chapter. Right, if I'm multiplying things with exponents, the exponents can be added. So that's going to be x squared. And then 3 times 6 is simply 18. And then, let's see, here we have minus 15x. And again, if you're wondering how I got x to the third, it's basically x to the 1 plus 2, right, times 9. And if you're wondering how I got x squared, x to the 1 plus 1 times 18. And then here there was no other variable. That's simply the minus 15x. So let's take another look at another example. Right, if I distribute this, I basically wind up having 2xy times 5x squared y plus 2xy times, and I write kind of big, so I'm going to run out of space here, 3xy squared plus 2xy times 7xy. And let's start adding, right, all the things that don't have an exponent power. The power implied is 1. So when you start to multiply this out, you basically have 2 times 5, and then x to the first times x squared, so that's x to the 1 plus 2, and then y to the 1 plus 1, plus, well, you know what, because we're going to take up all this room, let's just figure out one term at a time. How about that? So 2 times 5 is how many, right? It's 10. And then x to the 1 plus 2 is x to the third. And then y to the 1 plus 1. So that's one term. 10 x to the third y squared. So we took care of this first distribution. Now let's take care of this one, the second one. So you basically have, oops, I hit the page turning button. You basically have 2 times 3 times x to the 1 plus 1 times y to the 1 plus 2. Right, and that's going to equal a positive. 2 times 3 is 6. 1 plus 1 is 2. And 1 plus 2 is 3. And now this last term, right here, here's the third one. We have 2 times 7, x to the 1 plus 1, and y to the 1 plus 1. 2 times 7, right? This is positive 14, x squared, y squared. So you'll notice all these exponents and variables have different powers. So the final answer, right, is you're going to combine all 3 terms. So here's the answer. 10x to the third y squared plus 6x squared y to the third plus 14x squared y squared. So we'll have lots more examples, but here's another strategy for multiplying polynomials by a binomial.